Now question number 86. pH of a solution obtained by mixing 600 ml N/2 acetic acid and 200 ml N/2 NaOH will be. If these two are mixed, there's the possibility of the formation of buffer. Now, when this acetic acid is mixed with NaOH, weak acid is mixed with strong base. So there's the formation of salt of these two. Sodium acetate would be formed. Initially, the amount of this acetic acid is 600 ml. The volume is 600 ml and its concentration is N/2. Let's find out initial milli equivalent of this acetic acid. So we have the normality, that is 1/2. Then multiply it by its volume. So these are the milli equivalent for this acetic acid. These are 300 milli equivalents for this. Similarly, if we talk about NaOH, initially it is 1/2 and the volume is 200 ml which is mixed with it. So the 100 milli equivalents of this was there, but if we talk about this acetic acid, it was not formed. So that's why we can say there's no milli equivalent of sodium acetate. Now finally, when reaction occurs, the milli equivalent would becomes, for acetic acid, the reaction would start, they will combine, neutralization process occurs. So 100 milli equivalent of NaOH will be neutralized by 100 milli equivalent of acetic acid. So definitely there are remaining 200 milli equivalents of acetic acid would be there, and these would be consumed, and the formed milli equivalent of sodium acetate would be 100. In this way, we can say that the mixture that is formed here is an acidic buffer in which acid is present as well as salt of that acid with strong base is also present there. Now, it's a turn to find out the pH of that acidic buffer. pH is equals to pKa value plus log the concentration of salt upon the concentration of acid that is there in the buffer. Now, let's find out the pH value. pKa value is already given, that is 4.74. Have a look on the question. This is clearly given here. The pK value is 4.74 as well as the value of log 2 is also given. Let's find out the final value. If we talk about the concentration of salt, that can be found out with the help of the milli equivalent of the salt. Milli equivalent of the salt are 100. Now, its volume is also given, that is 600 ml that you have taken, but it is mixed with 200 ml of NaOH, so total volume is 800 ml. Now it should be multiplied by 10 raised to the power minus 3. So this is the concentration of salt divided by the concentration of acid also. That would be milli equivalent of acid, 200 into 10 raised to the power minus 3 divided by volume once again, 800. Now, on simplification, we will find out this is 4.74 plus log. In this case, a lot of values can be cut. It would becomes 1/2. This is log 1/2. Or simply we can say log 1 minus log 2. Or it can be written as 4.74 minus the value of log 2 is 0.3. And this would be 4.44. This would be the pH value for this acidic buffer. And this is given here in option 1. That's why this is my final answer. Now, after this, let's take next question. Question number 87. The value of Kc upon Kp will be highest for. First, we should know the relation between Kc and Kp. We know that Kp is equals to Kc RT raised to the power delta N. So what would be the value of Kc upon Kp? The value of Kc upon Kp is equal to 1 upon RT raised to the power delta N G. This is delta Ng. It means we have to consider the change in number of moles of gaseous product and reactant there. So delta Ng value we can calculate for each of the given reactions. In the first case, this delta Ng value is equal to 2 moles of gaseous product and 3 moles of gaseous reactant. It means it is -1. Further, for the second case, this delta Ng value is equal to 0. In third case, this delta Ng is equal to 1. Delta Ng value for the fourth case is 2. Now, with the help of this data, we can easily find out that this Kc upon Kp value would be maximum for that case where this delta Ng value is least. So, this delta Ng value is least in case of the first equation. That is why this is our correct answer also. And I'm just going to choose it as the correct one. Now, after this, let's take next question.
Question number 88. If helium gas is introduced in the following reaction mixture at equilibrium at constant volume, then you should always remember that if you add some noble gas or inert gas in an equilibrium mixture at constant volume, then there is no effect on equilibrium. So whether the reaction is this or some other reaction, if you are adding the noble gas or helium at constant volume, there would not be any change in equilibrium, and that's why this option 4 is the correct option for this question. Now, after this, let's take next question.
Question number 89. For an exothermic reaction, variation of K equilibrium with temperature can also be represented by. Here we have to just represent the relation between K equilibrium and temperature. Let us see the equation. Log K equilibrium is equal to log A minus delta H by 2.303 R to 1 by T. This is the expression. Now compare this with equation of straight line, because all of these graphs have the straight line. So y is equal to mx plus c. So this is the equation that we need to follow here. In this case, x is 1 by t and y is log K equilibrium. Where this is given, if you look at the given graphs, log K equilibrium is given at the y-axis in option 4 and 1 by t at x-axis. That is also in the option 4. And if we talk about the slope, that m is equals to minus delta h upon 2.303 R. This is the value for slope. And in this case, if the reaction is exothermic, it means delta H value is negative. Delta H value is negative. That's why overall slope becomes positive. And in this fourth option, slope is positive. At x-axis, you have taken 1 by t. At y-axis, you have taken log K equilibrium. That is why this is the graph which is correct for this. The similar graph is also present here in option 1 also, but this is incorrect because here the intercept is not there. That is why I'm not choosing this as the correct option. Only option 4 is the correct one. Let's choose it the correct option. I hope this question is clear to you. Let's take next question. Question number 90. This is the last question of the chemistry section. pH of a solution obtained by mixing equal volume of two solutions having pH 2 and pH 3 is log 55 also here, that has the value 1.74. Say the volume of solution 1 is equal to volume of solution 2. As per the question, both of these are equal and we have just assumed these are V. Now, pH of these solutions are given and from the pH, we can find out the concentration of each of these solutions. So, for the first solution, if we are talking about pH is 2, and if its pH is 2, its concentration is, in terms of molarity, suppose M1 it is 10 raised to the power minus 2. In the similar way, for the second solution, pH is 3 and this M2 value, molarity for the second solution, that would be 10 raised to the power minus 3. Now, we just want to find out the molarity of the final solution on the basis of which we can find out the pH of the final solution. So, we'll use the molarity equation MV dash, where M is the molarity of the final solution and this V dash is the volume of the final solution. should be equal to m1v1 plus m2v2. Let's place the values here. M we just want to find out. M1 is 10 raised to the power minus 2. Its volume is V. M2 is 10 raised to the power minus 3. Its volume is also V. Divided by the total volume of the solution, that is V1 plus V2. It means that would be final volume, that is V dash, and this would be the sum of the volumes of these two. So it would be 2V equal to 1 by 2 into 0.011. That is equal to 55 into 10 raised to the power minus 4. Now, just find out the pH value. pH value is equals to negative log of the concentration of the solution. And because we just want to mix two solutions, so the concentration of the final solution you have to take, that is 55 into 10 raised to the power minus 4. Now, if you solve this, you will find out that it would be 4 minus the value of log 55. That is given here 1.74. And on solving, it would come out to be 2.26. And this is the answer for this question. That's why I'm choosing option 1 as the correct option. I hope all the questions those we discussed today are clear to you. All the best for your results. Thank you so much for watching.